In Lesson 2, Interpreting Division of a Whole Number by a Fraction Visual Models, we went through 4 examples. Example number 1 was 4 divided by 1/5, okay? And visually, I wanted to show the students what that meant. So, one way to interpret this division problem is to say that we had 4 wholes. Each of these 4 wholes was divided into fifths, because 5 pieces make a whole from our denominator. And the question is really asking us, how many 1/5 pieces fit inside 4? 4, 5, I should have been counting out loud, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 1/5 pieces that fit inside 4. Okay. Another way to interpret this division problem is to say, what is 4 divided into a fifth? Okay, so I'm going to take a fifth. And I'm going to divide 4 into 1 out of 5 pieces. 4 divided by 1 box would mean that 4 went in every single box. And 4 times 5 is 20. 2 different ways to approach the same problem, okay, but the same answer. And a very important part is for the kids to start realizing, okay, you have 4 divided by 1/5. What multiplication problem could have gotten you to 20? And it's 4 times 5, okay? So we kept this one the same, and it looks like we took the flip or reverse of that, okay? Let's go on to example 2. Olivia has 5 oversized chocolate bars. She wants to break them into thirds to share with everyone at her table in the cafeteria. How many people will she be able to share her chocolate bar with? Okay, the division question being asked in this problem is 5 divided by 1/3. Okay, so again, I'm going to show you 2 different ways to do it. You could interpret it as having 5 wholes in your model, divided into thirds, 3 pieces, and you really want to see how many 1/3 pieces fit inside here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 1/3 pieces inside 5. Another way to interpret the problem is 5 divided into a third. So I'm going to take a third, and I'm going to divide 5 into it. 5 divided into 1 out of 3 boxes is going to be 5, because 5 divided by 1 is 5. And then 5 in every box would also give us an answer of 15. Okay, the division problem presented was 5 divided by a third, but the multiplication problem is really 5 times 3, which equals 15. Okay, I have 2 more examples that I'd like to go over with you before the end of this video. Number 1. Now, this is where I'm going to try to steer your thinking. I'm going to do this question 2 different ways. So 6 divided by 2/3. I'm going to draw 6 holes, and I'm going to break each one into thirds. Now in this problem, it differs from the first 2 that we did, because we're not looking for 1/3 pieces any longer. We're looking for 2/3. There's 1, 2, 3 sets of 2/3, 4, 5, 6 groups of 2/3, 7, 8, 9 groups of 2/3. If visually this way makes sense to you, please stick with it. I think it could get trickier. I really do think that 6 divided by 2/3, or 6 divided into 2/3 with this model is a little easier. 6 has to be divided into 2 out of 3 boxes. 6 divided by 2 is 3. And all 3 of the bars are going to total to an answer of 9. Okay, same problem. Now this one's a little different to see as a division problem or a multiplication problem. The division problem is 6 divided by 3 divided by 2/3. But if we went with the same method that we did with the first two, you're really taking 6 and you're multiplying it. Let's flip this second fraction and see if we can get 9. 6 times 3 is 18. 2 times 1 is 2. 18 divided by 2 is 9. Okay, so we're starting to see a little pattern here. The last example actually gives you a model and asks you to fill in the division problem. So 10 is getting divided by 2 boxes, which gives you 5 in every box. And that's really 2 out of 1, 2, 3, 4, 5, 6 boxes. And it's 5, 10, 15, 20, 25, 30 for the answer. Okay? And let's try to flip that. Let's do 10 times 6 over 2. Let's see if we still get 30. 10 times 6 is 60, divided by 2 times 1 is 2. 60 divided by 2 is indeed 30. And that's a summary of Lesson 2 from Module 2. Thank you for watching this video.